Right now, roughly 100,000 particles of invisible matter are passing through every square centimeter of our bodies. We don't feel them. They don't interact with our atoms, and we have no idea what they are. That was fine, until we pointed a $10 billion telescope at the edge of the universe and it started sending back data that shouldn't exist. In less than 2 years, the James Webb Space Telescope has produced over a dozen findings that directly contradict the physics we use to explain why matter holds together, why stars form, and why we feel solid when we're 99.9% empty space. Black holes older than the first star. Galaxies the math gives a 0% chance of existing. A universe expanding at 2 different speeds. Evidence the constants keeping our atoms stable might be drifting. And none of it is getting better. Every new data packet makes it worse. So what are we actually made of? And how long does it hold? We all know this planet has an expiration date. Sun heating up, asteroids, magnetic field decay. One way or another, Earth runs out. So we need a backup. And finding one has been one of the hardest jobs in science. Decades of work, thousands of researchers, billions of dollars, entire missions built to do one thing, scan the sky, and find a world where we could survive. In 2017, they thought the search was over. A telescope in Chile spotted 7 rocky planets circling a quiet star called Trappist 1, 40 light-years away. 3 of those planets were sitting at just the right distance from the star, where temperatures allow liquid water to stay on the surface. They were roughly the size of Earth. And that matters because when you have a rocky planet that size, that close to a star, the physics is straightforward. As the planet cools after forming, gases trapped inside the rock escape to the surface. Carbon dioxide, nitrogen, water vapor. It is the same process that gave Earth its first air. So these planets should have atmospheres. They should have the conditions for water. That is not hope. That is physics. And for 10 years, Trappist-1 was the best answer humanity had. So what happened when we actually looked? In 2023, the James Webb Telescope pointed its infrared sensor at Trappist-1b and measured the heat coming off the surface. If a planet has an atmosphere, even a thin one, the heat redistributes in a specific way. Webb saw nothing like that. Just bare rock radiating energy straight into space. No gas, no air, no envelope of any kind. One planet down. Maybe it was an outlier. In 2024, Webb checked Trappist-1c. Same instrument, same method, same empty answer. But wait, these planets are the right size, the right distance. They have had billions of years to produce gas. By every rule we understand about how worlds form, the air should be there. And it is not. So where did it go? What kind of force can reach across a solar system and peel the atmosphere off not 1 but 2 planets that by all rights should have one? And if our best option, the single most promising place we have ever found, is already stripped bare, what does that tell you about everything else out there? And honestly, we already learned what did it. And it does not make things better. According to the data Webb pulled from the Trappist-1 system, it was not an asteroid. It was not some random event. It was the star itself. The star those planets orbit. Trappist-1 hits its own planets with bursts of superheated plasma every few hours. 12 times more powerful than any model predicted. Each blast rips another chunk of atmosphere right off the surface, and the planets have to be close to the star because that is the only distance where enough warmth reaches them for life to even have a chance. But that same distance is what kills them. Too close to live. Okay, so is this just one bad star? What about the rest of them out there? 75% of all stars in the Milky Way are the same type as Trappist-1. 3 out of 4. This is not one broken system. But maybe if a planet is massive enough, it can take the hits and hold on to its atmosphere. And of course, scientists went looking for exactly that kind of planet. They took every world Webb has measured and sorted them on a simple chart, planet mass on one side, how much radiation it gets from its star on the other. and a hard line showed up. Picture a black line drawn in the air right in front of you. Everything above that line, life is possible. Everything below, life is impossible. Almost every planet they checked falls below that line. So the problem is still here. At any moment, our system could be done. And finding another one like it, where the star warms and protects instead of destroys, is one of the rarest combinations in the galaxy. Less than 8% of all stars are like our sun. So what do you do with that? Where do you even look? We are sitting on the one planet that worked, around the one type of star that does not kill its own worlds, and that star is still getting hotter. The odds were already against us before we pointed Webb at the sky, and now they are worse. But at least we know the odds, right? At least the numbers make sense. And maybe we figure it out someday. We have to. There is no other option. But here is the thing about those numbers. Every measurement we just talked about, the habitable zones, the shoreline, the 8%, all of it comes from physics. And it actually touches your life directly. Every drug you take, every plane you board, every GPS signal that tells you where you are, runs on the same laws of physics that might not be as solid as we thought. And the next thing Webb found is exactly why. After everything we just went through, there is one thing we are still holding on to. Time. We keep saying we have it. 1 billion years before the sun gets too hot. Maybe more if we find the right planet. The math says so. But where does that number actually come from? How do we know how much time is left? It comes from one measurement. How fast the universe is expanding. If you know that you can work out how old everything is, how far apart everything is, and how long until everything flies so far apart that nothing can survive anywhere, it is the only clock we have. So how confident are we that the clock is right? In 2023, a team at Johns Hopkins used Webb to check. They pointed at a star that exploded on the other side of the universe, and its light had been bent and split into 3 copies by a massive galaxy sitting in the way. Like looking at a candle through the bottom of a glass and seeing 3 flames. You measure the time gap between the copies and you get a clean distance. No guessing, no models, just geometry. Their answer was 73. So now we have a number. Is the argument over? No. Because a separate team used a completely different method. They took the oldest light in the universe, the glow left over from the Big Bang, and worked backward. Different instruments, different math, different assumptions. Their answer was 67. So which one is right? 73 or 67? Both methods are clean. Both have been checked for years. So maybe one team made a small mistake somewhere. Except the gap between those 2 numbers is not small. The probability of it being a random error is less than 1 in 3 billion. In science, that means it is not an error. It is real. And here is why that matters to you directly. If the real number is 73, the universe is expanding faster than we calculated. Dark energy, the force pulling everything apart, is stronger than we thought. And the window in which life can exist anywhere is shorter. How much shorter? Nobody knows. We have been planning around 1 billion years, and that number might be wrong, not slightly off, built on a measurement that contradicts itself. So right now we do not actually know how much time anything has left. And the people whose job it is to figure that out cannot agree on which answer is real, not because they have not tried, because the harder they try, the worse it gets. So who are these 2 teams, and why can they not just sit down and figure it out? The first is led by Adam Rees at Johns Hopkins, Nobel Prize winner. He has been measuring the expansion rate using supernovae for over 20 years. His number is 73, and he has bet his career on it. The second is Wendy Friedman at the University of Chicago, also one of the most respected names in cosmology. She used a different approach, recalibrated everything from scratch, and keeps landing closer to 67. These are not 2 random labs disagreeing about a technicality. These are 2 of the best people alive at this, and they are publicly telling each other the other one is wrong. So the obvious move is to bring in a third person. someone outside both camps with a completely independent method. In 2024, a team led by Daniel Skolnick and Dylan Brute did exactly that. They used a different type of supernova, a different calibration, a different data set, fresh eyes, clean start, and the result did not land on 73. It did not land on 67 either. It landed somewhere in between and agreed with neither. 3 methods, 3 answers. The problem did not shrink, it got bigger. And it is not like people have not tried to fix the models. Between 2023 and 2025, teams around the world tried everything. Maybe there is a type of dark energy that was stronger in the early universe and weaker now. Maybe gravity works differently at very large scales. Maybe there is a particle we have not discovered yet. They tested every patch they could think of, and none of them closed the gap. The gap just sat there, 2 times larger than any model can explain. So think about where that leaves us. We are standing on a planet that is running out of time, and the instrument we use to measure how much time is left is giving us contradictory answers. Every attempt to fix it has failed. The 2 people most qualified to solve it cannot agree, and the gap is not closing, it is growing. The foundation that all of modern cosmology is built on has a crack in it, and nobody knows how deep it goes. But maybe the real problem is not that we cannot measure the universe correctly. Maybe the real problem is what Webb found when it stopped looking at how the universe works and started looking at what it is made of. Because what it found changes what you think you are. Something out there is killing life, not just on planets around dangerous stars, not just in hostile systems, everywhere. And we know that because of what Webb found next. In 2024, it pointed at a galaxy outside the Milky Way and detected benzene, one of the core molecules your DNA is built from, just floating in open space in a completely different galaxy. That same year, it found a planet called CT-Char-B that has not even finished forming yet, and it already has organic molecules assembling around it on their own. So, the recipe for life is not rare, it is automatic. It builds itself anywhere there is dust and energy, and it has been doing that across the entire universe for 13 billion years. So life should be everywhere by now. There are 4 billion sun-like stars in the Milky Way. 1 in 5 has a rocky planet at the right distance for water. That is 800 million worlds with the right setup and billions of years to work with. And we have never heard from a single one of them. So life starts, but it does not survive. Why? In 1996, an economist named Robin Hanson proposed an idea called the Great Filter. Somewhere between dead chemistry and a civilization that can send a signal, there is a wall. A step that is so hard or so deadly that almost nothing gets past it. And we do not know where the wall is. Is it before us or ahead of us? In 2014, 2 astrophysicists, Tzvi Piran and Raul Jimenez, calculated that gamma-ray bursts, single explosions from dying stars powerful enough to sterilize an entire region of a galaxy, could have wiped the surface of 90% of all planets in the Milky Way at least once in the last billion years. Not a slow death. One flash and everything on the surface is gone, and the planet never knows it is coming. But even that does not fully explain it, because some planets should survive. Some should be in the right place at the right time. 800 million chances over billions of years, and not one signal. So maybe it is not one thing. Maybe it is not something we can even name yet. Maybe the universe has a way of stopping life that we have not discovered, because we have not been alive long enough to see it happen here. And that is the part that sits with you. We do not know what it is. We do not know if it has already passed us or if it is still ahead. We just know that 800 million worlds had everything they needed and none of them made it. And whatever stopped them, we have no reason to believe it cannot reach us. But maybe somewhere something did get through. Webb found what looks like a sign of life on another world, and what it found does not make this better. In 2023, Webb pointed at a planet called K2-18b, 8.5 times the mass of Earth, 120 light-years away, and in its atmosphere it detected dimethyl sulfide. On Earth, dimethyl sulfide is only produced by living organisms, mostly ocean plankton. There is no known geological process that creates it. So when Webb saw it in the atmosphere of another world, it meant exactly what you think it means. Something on that planet might be alive. So did we find life? Maybe. But here is the problem. K2-18b is not a place you can go. The surface temperature is over 120 degrees Celsius. The atmosphere is thick with hydrogen and methane. If there is an ocean, it is not water you would recognize, and the pressure would crush anything built like you before you got anywhere near the surface. So, the one place where Webb found a possible sign of life is a world that would kill you in seconds. The chemistry survived. You would not. And that is strange, because it means whatever is out there that keeps killing life everywhere else either missed this planet or could not reach it. But what survived is not anything like us. It is something that thrives in conditions we cannot even get close to. So maybe life does get through the filter, but only the kind of life that can handle hell, and the kind that needs a calm, stable world like ours. The kind that builds eyes and lungs and brains. Maybe that kind never makes it. But here is the part that really gets to you. We do not need to go 120 light-years to check if life exists somewhere else. Europa, one of Jupiter's moons, is right here in our own solar system. In 2023, Webb detected carbon dioxide on its surface. And we already know there is a liquid ocean underneath the ice, salt water, kept warm by the gravitational pull of Jupiter squeezing the moon's core. An ocean with energy, with carbon, with the same chemistry that started life on Earth. It has been there for billions of years, and we have never sent anything to check. Not once. There might be life closer to us than any star we have ever studied, and we have not looked. So what are we actually afraid of finding? Because the next thing Webb turned its instruments toward was not a planet. It was not a star. It was the empty space between them. And what it found there should not exist. Right now, something is pulling every atom in your body apart. Not fast enough for you to feel. Not yet. But it is accelerating. It is called dark energy, and it makes up 68% of everything that exists. Nobody knows what it is. All we know is what it does. It stretches space itself. The distance between everything is growing, and every year it grows faster. So how do we know it is real? In 2023, Webb caught light from a supernova called SNH0PE that exploded 9 billion years ago. A galaxy cluster between us and the explosion bent the light and split it into 3 images, arriving at different times. The time gaps told scientists exactly how far away the explosion was and how fast the space between us and it has been stretching. The answer was clear. The expansion is not slowing down, it is speeding up. So what does that mean for us? First galaxies outside ours vanish. The space between us and them stretches faster than their light can cross it. They are still burning, but we will never see them again. Then it reaches our galaxy. Stars pull away from each other, planets from stars. And if it does not stop, and nothing we have measured suggests it will, it reaches smaller things, molecules, then atoms. Physicists call this the Big Rip. The same force pulling galaxies apart right now eventually pulls apart every atom in your body from the inside out. When? Nobody can say, because nobody knows what law dark energy follows. We are inside something that is tearing itself apart and we cannot even name it. But is this the first time? Has the universe always been pulling itself apart, or is this something new? In 2023, Webb surveyed over 250 galaxies from the first 2 billion years of the universe. What it saw was nothing like today. Collisions, mergers, galaxies ripping each other apart, no structure, no order. The universe spent most of its history in chaos. Everything we see now, the stable orbits, the calm sky, the predictable seasons, showed up late. So the chaos is where it started. And if dark energy keeps accelerating, the chaos is where it ends. And we are in the middle, on a planet that only exists because the chaos paused long enough for something to form. How long does the pause last? Nobody can tell us. But maybe none of this matters if we do not understand how it started. Because when Webb looked at the first few 100 million years, it found objects so massive that no law of physics can explain how they got there that fast. And they are everywhere. There is a black hole at the center of our galaxy, right now, 4 million times the mass of our sun. Everything in the Milky Way, every star, every planet, every solar system, including ours, is orbiting around it. We have been circling it since the Earth formed, and we will keep circling it until something stops. It is called Sagittarius, a star, and most of the time it just sits there, does nothing, takes in a little gas, stays quiet. That is the version we know. But about 2 to 4 million years ago, it woke up. It started pulling in massive amounts of gas and matter, and when it did, it fired 2 jets of energy so powerful, they punched through the entire galaxy above and below the disk. We can still see the scars. They're called Fermi bubbles, 2 structures of superheated gas stretching 25,000 light years in each direction. Not some ancient black hole at the edge of the universe. Ours. Our black hole did that. And then it went back to sleep. So what woke it up? What triggers something like that? And how do we know it will not happen again? Because when Webb looked at the first 500 million years of the universe, it found supermassive black holes everywhere, fully formed, already anchoring galaxies, and they were not sleeping. They were feeding constantly, firing radiation in every direction. By 2024, Webb had spotted them as early as 430 million years after the Big Bang. There should not be enough time for them to grow that big by any process we understand. And across every deep field image Webb took, there were hundreds of compact bright red objects packed into the early universe. Tiny things with the spectral signature of supermassive black holes actively feeding inside them. So what does that tell us about ours? That what we see right now, a quiet, well-behaved black hole sitting still, is not how these things normally act. Everyone Webb found in the early universe was violent, constantly. So is ours actually calm, or is it just between meals? Because if it wakes up and fires another jet, and this time the angle is closer to our solar system, the radiation hits the heliosphere, strips the magnetic protection, and the ozone layer is gone. Not in 1,000 years. In months. We cannot predict it. We cannot see it coming because by the time the light from the jet reaches us, the radiation is already here. And you would think a black hole at the center of the galaxy is the worst thing that can reach us without warning. It is not even close. When a massive star collapses, it does not just die. It fires a beam of energy so powerful that 10 seconds of it carry more energy than our sun will put out in 10 billion years. That beam crosses the galaxy at the speed of light. Anything in its path is gone, not over centuries, in seconds. And in 2024, Webb detected one of these bursts from when the universe was less than 1 billion years old. So how long have they been going off? Since almost the beginning. How many planets had something alive on them when a beam crossed their sky? How many times has life gotten started somewhere and then just stopped? In a flash, it never saw. In 2004, one went off inside our own galaxy, a magnetar 28,000 light years away. And even at that distance, it disrupted Earth's ionosphere. That was a weak one. A full collapse within a few thousand light years pointed in our direction, and the ozone is gone in hours. No warning sign, no buildup. The beam moves at light speed, so the moment you detect it is the moment it arrives. The sky changes color, and by then, there is nothing left to do. So what is worse than something that kills you in a flash? Something that does it slowly, and you never see it. In 2023, Webb and Hubble found a black hole that had been thrown out of its own galaxy. traveling at 2.2 million miles per hour through open space. And behind it, a trail of newborn stars. As it moved through clouds of gas, its gravity alone compressed everything nearby and ignited new stars in its wake. It was not building anything on purpose. It was just passing through, and everything nearby changed. So what happens if something like that passes near our solar system? It does not need to touch anything. Gravity alone pulls a planet out of its orbit. Earth shifts closer to the sun, and the surface burns. It shifts further, and everything freezes. And black holes do not glow. They do not send a signal. We found this one because it left a trail. How many are out there without one? How close is the nearest one to us right now? And would we even know before the orbit starts to shift? Every few years, an asteroid passes close enough to Earth that someone has to calculate whether it will hit us. And every time the answer comes back the same, it will miss. By this much, at this speed, on this trajectory. And we trust that answer because the math behind it has been tested for decades. The same math that tracks an asteroid tracks how planets orbit, how satellites hold position, how gravity pulls everything toward everything else. If that math is right, we can see what is coming. So what happens when it turns out to be wrong? In 2023, Webb looked at the early universe and something was off. Objects were glowing far brighter than any calculation said they should. Not one or two. Over 300 across multiple observations. Scientists went back and reworked everything. Changed the inputs, adjusted the assumptions, ran it all again. By 2025, the new numbers were closer, but still off. A gap twice as large as anyone can explain. 300 objects brighter than every version of every calculation we know how to build. We have adjusted everything there is to adjust, and it will not close. So if the math cannot get the brightness of something right, how confident are we that it can tell us where an asteroid will be in 6 months? How confident in any trajectory, any distance, any margin of safety? And it gets worse. Webb found fully formed galaxies from when the universe was only 500 million years old. Billions of stars already pulled together into structure. By everything we understand about gravity, that should take 2 to 3 billion years. Which means either there was more mass than we know about, or gravity was stronger back then than it is now. And if gravity changes, then what is it right now? Because gravity is what keeps Earth where it is. It keeps the moon in place. It keeps the atmosphere from drifting off into space. Everything that makes this planet livable depends on gravity being exactly what we think it is. And we just found out it might not have always been. But the next thing Webb found has nothing to do with gravity or math or deep space. It is 4 light years away. It might be a planet, and it is the closest thing to us that has ever shown a signal. Alpha Centauri, the closest star to us, 4 light years away. If we are ever going to reach another star, it will be this one first. And in 2025, Webb picked up a thermal signal coming from it. Something in orbit around that star is giving off heat. Could be a planet. Could be a dust cloud. Could be nothing. We cannot tell. The nearest star in the entire sky, and we do not know if there is a planet there. So how much of what is out there are we actually seeing? If we cannot figure out what is happening 4 light years away, what are we missing at 10? At 100? At 1,000? And it is not just distant stars. Europa, one of Jupiter's moons, not light years away, right here, same solar system. In 2023, Webb found carbon dioxide on its surface, not deposited from the outside, pushed up from below, from a liquid saltwater ocean underneath the ice. An ocean kept warm by Jupiter's gravity squeezing the moon's core. So there is liquid water, energy, and carbon all in one place. Those are the same conditions that started life on Earth, and they have been there for billions of years. Has anything started down there? We do not know, because we have never sent anything to look, not once. So what does it mean if something is alive under that ice? It means starting life is not the hard part. Keeping it alive is. And if starting is easy, then it has been starting all over the galaxy for billions of years, on every world where the conditions line up. So why is nobody out there? Why has none of it lasted? What is the thing that stops it every time? Is it something we have already seen or something we have not? And wherever it is, whatever it is, we have not passed it yet. It is still ahead of us. And the next thing Webb found might be the closest we have come to seeing it, because it watched a star die. And what came out of that death is the same thing that made you. Every atom of iron in your blood was made inside a star that died. The calcium in your bones, the oxygen in your lungs, the carbon in every cell of your body, none of it was here when the solar system started forming. It was built in the core of a star that burned through its fuel and collapsed before our sun was born. When it went, it scattered everything it had made across space, and some of that debris clumped together and became this planet and eventually became you. So you exist because something was destroyed. That is not a metaphor. That is literally what happened. But how violent was that destruction? And how close does it have to be before it stops creating and starts erasing? And Webb just showed us this process started earlier and hit harder than we thought. In 2024, it found the most distant supernova ever recorded. A star that died when the universe was less than 2 billion years old. The earlier stars were enormous, hundreds of times more massive than our sun. And when they went, the blasts were tens of times more powerful than anything we see today. Each one wiped out everything nearby while scattering the heavy elements that would eventually become planets and people somewhere else. One event, two outcomes, and you cannot have one without the other. So how many worlds were just starting to build something alive when one of these went off next to them? How many times did the universe hand out the ingredients for life and then take them back in the same moment? So the process that made you is still going. Stars are still dying, still scattering. And one of them is close, Betelgeuse, a red supergiant 650 light years from Earth. It is near the end of its life, already dimming and brightening in ways nobody can predict. When it goes, it will be the brightest thing in the sky for months. But that is not the problem. If the collapse produces a focused beam of radiation pointed in our direction, it reaches the ozone layer and strips it in weeks. The same kind of event that built every atom you are made of aimed directly at the planet you are standing on. So what do you do with that? The force that created you and the force that can end you are not two different things. They never were. And is that just how the universe works? Does it build and destroy with the same hand everywhere and always? Because the next thing Webb found says yes. And it found it at the very beginning, in the first few 100 million years, where something impossible was already waiting. In 2024, Webb found the most distant galaxy ever observed. It is called JWST 140, and the light from it has been traveling for over 13.5 billion years. When that light left the galaxy, the universe was only 290 million years old. Less than 2% of all of time had passed. And at that point, matter has barely had time to cool and clump. The first stars are just starting to ignite. There should be small dim smudges of gas, maybe a few clusters starting to pull together. Nothing more. But that is not what Webb saw. This galaxy is bright. It is large. It is already producing heavy elements and organizing them into something that looks like it took 1 billion years to build. And it was there at 290 million. So how do you pull that much matter together that fast? What process does that when every simulation we have run says it takes 3 to 4 times longer? And it is not alone. Across every deep field image, the same pattern shows up. The closer Webb looks to the beginning, the more it finds already finished, already massive, already organized. Like finding a city in a place where the concrete has not had time to dry. Who built it? When? And with what? Because every rule we have says the universe starts simple and gets complex over time. Webb is showing us it was already complex at the start, so if we do not understand how those first structures formed, then what do we actually understand? Because the gravity that pulled those early galaxies together is the gravity holding our planet in orbit right now. If it worked differently back then, how do we know it is not changing now? How do we know the force keeping Earth where it is today is the same force that will be there tomorrow? We built everything on the idea that the rules stay the same. And at the very beginning, they either worked differently or something else was doing the work for them. And we do not know which. So where does that leave you? In a universe where every answer Webb has found has made the questions worse. And the biggest one is still ahead. 14 discoveries. Every single one of them took something away. And not one of them gave anything back. So what do you do now? Where do you put your feet? You're on a planet with an expiration date, orbiting a rare star, surrounded by invisible forces pulling everything apart on a schedule nobody can calculate. The ingredients for your body are scattered across every galaxy Webb has looked at, and nothing else made from those ingredients has survived long enough to make a sound. So what are you? Not the species, not a number in a statistic. You. The one asking the question right now. Because here is what does not make sense. The universe does not care. Webb has made that clear. It builds and destroys with the same process. It strips atmospheres and scatters the building blocks of life in the same explosion. It has been doing this for 13.8 billion years, and in all that time nothing out there has lasted. But you are here, aware of all of it, able to look at the edge of time and understand what you are seeing. How? Out of everything the universe has produced, how did it produce something that knows it exists? What is consciousness? Where does it come from? Is it rare or is it everywhere? Does it survive what kills everything else, or does it disappear with it? And if the universe is not for you, then what are you for? Because the next thing Webb found is not about space. It is about what happens when matter gets complicated enough to ask that question. And the answer is not what you would expect. Take a hydrogen atom, the simplest thing in the universe. One proton, one electron. It does not think. It does not feel. It does not know it exists. Now take 100 trillion of them and arrange them with oxygen and carbon and nitrogen and a few dozen other elements in a very specific way. And suddenly it thinks, it feels, it knows it is alive. That is you. You are hydrogen that got complicated. And the question nobody can answer is where in that process did the knowing start? Because it does not stop. The universe keeps pushing matter toward complexity. Hydrogen collapses into stars. Those stars forge heavier elements, and when they die, they scatter them. The heavier elements find each other, form organic molecules, and the organic molecules start building cells. Then something happens that nobody can explain. At some point along that chain, the chemistry starts to be aware. When? At which step? Is there a line between dead chemistry and living chemistry, or does one slide into the other so gradually that there is no line at all? In 1995, Paul Davies proposed that life is not a freak event, that the laws of physics are set up in a way that drives chemistry toward biology wherever conditions allow, not by accident, by design of the rules themselves. And if that is true, then what are you? Not a miracle, not a one-time accident on one lucky planet. You are what matter does when it has enough time. A chemical reaction that ran long enough to become aware of itself. And if that is just what matter does, then it has done it before. Somewhere out there, it assembled something that could think, and then something destroyed it. And it will do it again. And something will destroy that too. So is that all consciousness is? A temporary stage that matter passes through before the next extinction hits? Does it keep starting over? Has it started and stopped 1,000,000 times across the galaxy while we sit here thinking we are the first? And is there something past this? A step after consciousness that we cannot imagine because we have not reached it yet. The universe has been running this process for 13.8 billion years. We are 300,000 years old. What makes us think we are the finished product? Because without something to observe it, the universe might not work at all. And that is not philosophy, that is physics. In 1927, Werner Heisenberg discovered something that broke the way we think about reality. At the smallest scale, the scale of atoms and particles, things do not have a definite state until something interacts with them. Before that, they exist in every possible state at once. An electron is not here or there. It is here and there and everywhere in between until the moment it is measured. Then it picks one. This is not a theory. It has been tested thousands of times over almost 100 years. It is one of the most confirmed facts in all of physics. And nobody knows why it works this way. So what counts as a measurement? That is where it gets strange. A rock sitting next to a particle does not collapse it. A camera in an empty room does not collapse it. Something has to interact with the particle in a specific way and record the result. And for almost a century, physicists have been arguing about what that something is. In 1961, Eugene Wigner took it further and said, maybe consciousness itself is what causes the collapse. That without a mind to register the result, the particle stays in every state forever. Most physicists today would not go that far. But ask any of them what actually triggers it, and you get silence. The math works, the predictions are perfect. But why it works is a blank. And everything Webb has shown us points in the same direction. The universe pushes matter toward complexity, toward chemistry, toward biology, toward awareness, over and over, everywhere. And quantum mechanics says that without observation, reality does not settle into a definite state. So does the universe need observers. Not want them. Need them. Is consciousness how the universe makes itself real? Did matter spend 13.8 billion years building something that could look at it because it does not fully exist until something does? We cannot prove that. Maybe we never will. But we cannot ignore it either because the physics behind it is tested and confirmed. And observers keep showing up everywhere Webb has looked. So maybe you are not an accident. Maybe you are not disposable. Maybe the universe has been building toward you since the first hydrogen atom cooled. Not because you are special, but because without you, it does not work. But you might be the only part of it that can care about anything. But remember that galaxy Webb found at the very beginning. Jades. The one that should not exist. By the time Webb took that image, the galaxy had been dead for billions of years. And it is not the only one. Every photograph Webb takes is a lie. Not because the data is wrong, because the image shows you something that does not exist anymore. The light from JWST 14-0 left that galaxy 13.5 billion years ago. The galaxy you see in the image is not there. It has changed beyond recognition, or it is gone entirely. And the light from the Trappist 1 system left 40 years ago. What Webb measured is not what those planets look like now. It is what they look like when you were being born. Every single thing Webb has ever shown us is a ghost. And it is not just Webb. Look up at the sky tonight. The light from the nearest star left 4 years ago. The light from the nearest large galaxy left 2.5 million years ago. You're not looking at the universe, you're looking at the past. Every direction you turn is a different depth of time. Close objects are recent past. Far objects are ancient past. And nowhere in any direction are you seeing now. Now does not exist anywhere except the exact point where you are standing. So what is now? Where is the present? Is there a version of the universe that exists all at once in a single moment? Or is that an illusion? Because time does not move at the same speed everywhere. If you are moving fast, time slows down for you. If you are near something massive, time slows down for you. Two people in different gravitational fields are not in the same now. Their clocks tick at different rates. GPS satellites correct for this every single day, or your position drifts by kilometers. So whose now is the real one? Yours. The satellites. The astronauts on the space station whose clock runs faster than yours. Webb shows this every time it shoots a deep field image. It captures light that left different objects at different times. In one single image, you see a galaxy from 300 million years after the Big Bang next to a galaxy from 10 billion years later, next to a star in our own galaxy from 50 years ago. 3 eras landing on the same sensor at the same moment. So, which one is real? Are all 3 happening right now? Did the first one stop existing 13 billion years ago? Or is it still out there and we are just getting the news late? If the past is still arriving, then in what sense is it past? And if now is a local illusion and the past is still traveling toward us, then what about the future? Is it already out there too? Is someone somewhere receiving light right now that shows them what happens to us next? And if the future is already traveling through space, does that mean it is fixed? That every choice you think you were making was made before you made it? We do not know. And we might not be able to know. Because it is not just time that might be an illusion. Everything you see and touch and stand on might be one too. And that is not speculation. It is tested physics. You are standing in a room. You see walls, a floor, objects at different distances. You walk forward and things get closer. Everything tells you this room has depth. That space has 3 dimensions. But in 1997, Juan Maldacena proved mathematically that everything happening inside a 3-dimensional space can be perfectly written on a flat surface around it. Like a sticker that contains all the information about what is inside the box. Not approximately, perfectly. Depth. The feeling that there is space in front of you might not be a real property of the universe. It might be how your brain reads something flat. And this is not just math on a page. In 2017, a team tested it against real gravitational data and the results matched. In 2023, another group showed that quantum entanglement patterns behave exactly as the model predicts. So does the universe actually have 3 dimensions, or does it just look that way? And if it is just the way it looks, then everything Webb has photographed, every galaxy, every black hole, every planet, can be described by information on a flat surface, including you, including your thoughts, including the feeling you're having right now that this cannot possibly be true. So if reality might be a projection, then what is real? Can you even answer that from inside the projection? Is there an outside to get to? In 2003, Nick Bostrom pushed it further. If any civilization ever gets advanced enough to simulate a conscious mind, then statistically, there are far more simulated minds than original ones. The odds that you are the real one are almost 0. And the holographic principle says the universe might already work this way. The information is the reality. There is nothing behind it to peel back and check. And you cannot test your way out. If you're inside a projection, you would see exactly what we see. A universe that follows rules. Rules that break at the edges. Measurements that contradict each other. A beginning that is too organized. Things that exist where they should not. Everything Webb has found fits a universe that is real. And it fits one that is not. And there might be no experiment that tells you which. So what do you hold on to when the ground you are standing on might be information pretending to be solid? What do you trust when you cannot prove that trust itself is real? And still, the universe exists. Something is here instead of nothing. And nobody has ever been able to explain why. You are standing in a room. You see walls, a floor, objects at different distances. You walk forward and things get closer. Everything tells you this room has depth. That space has 3 dimensions. But in 1997, Juan Maldacena proved mathematically that everything happening inside a 3-dimensional space can be perfectly written on a flat surface around it. Like a sticker that contains all the information about what is inside the box. Not approximately, perfectly. Depth. The feeling that there is space in front of you might not be a real property of the universe. It might be how your brain reads something flat. And this is not just math on a page. In 2017, a team tested it against real gravitational data and the results matched. In 2023, another group showed that quantum entanglement patterns behave exactly as the model predicts. So does the universe actually have 3 dimensions, or does it just look that way? And if it is just the way it looks, then everything Webb has photographed, every galaxy, every black hole, every planet, can be described by information on a flat surface, including you, including your thoughts, including the feeling you are having right now that this cannot possibly be true. So if reality might be a projection, then what is real? Can you even answer that from inside the projection? Is there an outside to get to? In 2003, Nick Bostrom pushed it further. If any civilization ever gets advanced enough to simulate a conscious mind, then statistically there are far more simulated minds than original ones. The odds that you are the real one are almost zero. And the holographic principle says the universe might already work this way. The information is the reality. There is nothing behind it to peel back and check. And you cannot test your way out. If you were inside a projection, you would see exactly what we see. A universe that follows rules, rules that break at the edges, measurements that contradict each other. A beginning that is too organized. Things that exist where they should not. Everything Webb has found fits a universe that is real, and it fits one that is not. And there might be no experiment that tells you which. So, what do you hold on to when the ground you are standing on might be information pretending to be solid? What do you trust when you cannot prove that trust itself is real? And still, the universe exists. Something is here instead of nothing. And not just exists. It works. Stars form, elements fuse, planets cool, chemistry becomes biology. The odds of that happening by accident are so small that when you see the actual numbers, you will not believe them. Stars are dying faster than they are being born, right now. Across the entire universe, Webb can see it. When it looks at nearby galaxies, it sees star-forming regions producing less and less. When it looks at the deep field, it sees the peak was billions of years ago. The universe made most of its stars early. What is left now is the tail end. And the tail is getting shorter. So follow that forward. Every star that is burning right now will eventually run out of fuel. The massive ones go fast, millions of years. The medium ones, like our sun, take about 10 billion. And the smallest ones, red dwarfs, burn so slowly they can last trillions of years. But even they run out. And when the last red dwarf uses the last of its hydrogen and fades, there is nothing left to replace it. No new gas clouds collapsing, no new fusion igniting. The universe goes dark. Not dark the way night is dark, where you know the sun is coming back. Dark the way nothing is burning anywhere ever again. And what is left? Scattered matter so thin that nothing will ever touch anything else again. Black holes still exist, but even they do not last. They leak energy so slowly you would never notice, but over trillions upon trillions of years they shrink and eventually vanish. And after that there is no light, no heat, no structure, nothing changes, nothing moves. Nothing interacts with anything because everything is too far apart. The universe is still there, but it is empty in every way that counts. So how long? When does the last star die? The last red dwarfs will burn for about 100 trillion years. The universe right now is 13.8 billion years old. That means we are in the first fraction of 1% of the time stars will exist. The very beginning. And right now on this planet, in this sliver of time, something is alive that can look up and understand all of this. What are the odds of that? What are the odds that you exist right now during the only window when the universe is lit? And if Webb can see the star formation slowing down, then we are watching the window close in real time. But here is what it also found. Inside those dying clouds of gas, something is being built right now. And it looks exactly like what built us. In 2022, Webb pointed at the pillars of creation. Hubble had photographed them before. tall columns of gas and dust in the Eagle Nebula. But Hubble could only see the surface. Webb sees through dust. And when it looked inside those pillars, it found what Hubble never could. Newborn stars, hundreds of them, still forming, still pulling gas onto themselves and igniting for the first time. Some of them only a few 100,000 years old. In cosmic terms, they switched on yesterday. And around many of those stars, Webb can see something else. Flat spinning rings of gas and dust circling the young stars like water going down a drain. Protoplanetary disks. The raw material for planets. Right now, inside those disks, dust grains are sticking together. Clumps are forming. Some of those clumps will become rocks, and some of those rocks will become planets. And some of those planets will cool and develop atmospheres and oceans. How do we know? Because that is exactly what happened to Earth 4.5 billion years ago. We are watching it happen again to someone else. And it is not just in the pillars. In the Carina Nebula, Webb found jets of material shooting out of stars so new they have not finished forming yet. Protostars still eating their birth clouds. And around them, the same disks. And in some of those disks, Webb detected water vapor. Not ice, vapor. On GJ486, B, a planet so hot its surface is molten rock. There is water in the atmosphere where it should have been baked off billions of years ago. Either it is being replenished from somewhere below, or we do not understand how water survives on hot planets. Either way, water is harder to kill than we thought. It shows up where it should not. It survives where it cannot. But none of it might last. The universe is dying. Stars are fading. The window is closing. And inside that closing window, the process that made you is running right now on thousands of new worlds. Building new planets, filling them with water, starting the chemistry. Is it building new life right now? Will something wake up on one of those worlds 1 billion years from now and wonder if it is alone? Will the universe still be lit when it does? And what does it mean that we are here at the one moment when we can see both the building and the dying at the same time? Because Webb found a single star, the most distant individual star ever seen, and it has been dead for billions of years. But we are just now seeing it alive. Its name is Earendel. It means morning star in Old English. Webb found it in 2022, and it is the most distant individual star ever observed. The light from it has been traveling for 12.9 billion years. When that light left the star, the universe was less than 1 billion years old. There were no planets like Earth, no solar systems like ours, no life anywhere that we know of. Just young, massive stars burning through their fuel fast. And Earendel was one of them. How massive? Massive enough that it was probably already dying by the time its own light had crossed its solar system. By now, it is gone. A star that size burns fast and dies fast. It exploded within a few million years of the light we are seeing leaving its surface. And when it exploded, it scattered heavy elements into the gas around it. Those elements ended up in the next generation of stars, and the next, and eventually in a cloud of gas that collapsed and became our sun, and our planet, and you. So when you look at the image of Earendel, you might be looking at one of the things that had to die for you to exist. Not metaphorically. The atoms in your body pass through stars like that one, and you are seeing it burn for the first time at the exact moment you are made of what it became. What do you do with that? How do you look at something that made you and know it has been dead for 12 billion years? And there are more of them. Everywhere Webb points, every deep field image is full of stars and galaxies that burned and built and scattered and are gone now. All of them part of the same chain that ends with you standing here. And it is not finished. Right now, somewhere in a nebula, a star is forming that will explode in a few million years, and the elements it throws off will end up in a planet that does not exist yet, around a star that has not ignited yet. And on that planet, something might wake up and look at our sun the way we look at Earendel. Already dead by then. But the light just arriving, so does any of it last? Does anything survive, or does everything just feed the next thing and disappear? Because Webb found something underneath all of this. The invisible structure that connects every galaxy to every other galaxy. And it is not what we thought it was. Every galaxy in the universe is connected to every other galaxy, not by gravity alone, by structure. Thin filaments of matter stretching millions of light years between galaxy clusters like threads in a web. Where the threads cross, galaxies form. Where they do not, there is nothing. Voids hundreds of millions of light years across with almost no matter in them at all. The universe is not random. It has a web, and Webb can see it. In 2023 and 2024, Webb traced this web further and in more detail than anything before it. Filaments of gas and dark matter running between galaxy clusters across billions of light years. And the pattern is the same everywhere. At every distance, at every age, the web is there, which means it was there from almost the beginning. The universe did not scatter galaxies randomly and let them sort themselves out. Something organized them. Something built the web before the first stars ignited. What? We do not know. And it gets worse. 85% of what the web is made of is dark matter. We have never detected it directly. We do not know what particle it is. We do not know what force it responds to. We only know it is there because without it, galaxies spin too fast to hold together. They should fly apart, and they do not. Something invisible is gripping them, and that same invisible material is what the filaments are made of. The entire structure of the universe is built from something we cannot identify. But without it, none of this holds. No galaxy stays together. No star system keeps its shape. Everything flies apart. So you are living inside a web you cannot see. Built from material you cannot detect. Organized by a process nobody understands. And it has been there since before the Earth existed. Before our galaxy existed. We are pinned to it like a bead on a string, and we did not know the string was there until 20 years ago. So how much else is holding us in place that we have not found yet? How many other forces are shaping what happens to us right now that we cannot measure? We are looking at 5% of what exists and calling it the universe. The other 95% is invisible, and it is running everything. And that might be the most honest thing Webb has taught us, not what is out there. How little of what is out there we can actually see, and what that means for everything we think we know. We said there were 3 answers to why the constants are what they are. Design, look, or everything exists. That third one, the one most physicists actually take seriously. It has a name, the multiverse, and it is not science fiction. It comes directly out of the math. When you solve the equations of quantum mechanics one way, you get the universe we see. One set of outcomes, one history, one you. But the equations do not say the other solutions are wrong. They are just as valid mathematically. In 1957, Hugh Everett proposed the simplest interpretation. Every possible outcome happens. All of them. Every time a particle could go left or right, it goes both. And the universe splits. Not into 2 places. Into 2 versions of everything. You in one, a different you in the other, both real, both continuing, and neither one knows the other exists. How many versions? There is no upper limit. Every quantum event that has ever happened in 13.8 billion years has branched. The number of parallel universes, if this is true, is so large that there is no way to write it down. And in most of them, you do not exist. In most of them, Earth does not exist. In most of them, the constants are different, and nothing ever formed at all. But in some of them, everything happened exactly the way it did here. And in some of them, it happened almost the same way, except one thing went differently. One decision, one mutation, one asteroid that missed instead of hit. And you cannot reach any of them. You cannot see them, you cannot prove they are there. But the math allows them. The physics allows them. And there is no observation Webb or anything else has ever made that rules them out. So if they exist, then everything that can happen has happened. Every version of your life has played out somewhere. Every choice you did not make was made. Every person who died is alive in another branch. And every catastrophe that did not happen here happened somewhere else. Does that make anything better? Does it make anything worse? Or does it not change anything at all because you are stuck in this one? And that is the part that matters. Even if everything exists, you only experience one version. This one, where the stars are dying and the window is closing and the web is invisible, and the past is still arriving, and you are made of dead stars, standing on a planet that will not last. So what do you do with the one version you got? Because Webb is not going to answer that for you. Nothing is. But there is one more thing it found that might change how you think about the question. And it is the oldest light in the universe. There is a wall of light surrounding us in every direction. It is the oldest thing we can see. Not the oldest thing that exists. The oldest thing that is visible. It was released about 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and light could finally travel without hitting something. Before that, everything was so hot and dense that photons could not move. They just bounced. And then, one moment, the universe cleared, and all that trapped light was released at once, in every direction, and it has been traveling ever since. We call it the cosmic microwave background, and it is still arriving. When you tune a radio to static, part of that static is this light. Photons that have been traveling for 13.8 billion years landing on your antenna. You have been bathed in the first light of the universe your entire life. Every person who has ever lived has been hit by it. And nobody noticed until 1965, when two engineers at Bell Labs found a hum in their equipment they could not get rid of and accidentally discovered the echo of the beginning of everything. And here is what makes it strange. It is almost perfectly uniform. The same temperature in every direction. 3 degrees above absolute zero everywhere you look, which should not be possible. Regions of the universe that have never been in contact with each other, that are so far apart that nothing could have traveled between them even at the speed of light in the entire age of the universe, are the same temperature. How? How do two places that have never touched end up exactly the same? It is like finding two strangers on opposite sides of the planet wearing the same outfit down to the thread count. Nobody coordinated it. Nobody could have. And yet, it matches. The best explanation we have is inflation. That in the first fraction of a second, the universe expanded faster than light. That everything we see was once a tiny patch smaller than an atom, and it all had the same temperature because it was all the same point. And then it inflated so fast that the uniformity was locked in before anything could change it. Does that sound like something we understand, or something we gave a name to so we could stop thinking about it? Because inflation solves the problem, but nobody knows what caused it. Nobody knows what stopped it. Nobody knows if it is still happening somewhere outside our observable universe, right now inflating new regions into new universes with new constants and new versions of everything. So, the oldest light you can see is a photograph of a mystery. A wall that looks the same in every direction for reasons we named but did not solve. And behind that wall is everything we cannot see. Whatever happened in the first 380,000 years, whatever set the constants, whatever decided this universe would be one where something could wake up and ask why it exists, all of it is behind the wall, and we will never see past it. But Webb pushed closer to it than anything before, and the closer it got, the less things made sense. Because right up against that wall, there are structures that had no time to form, galaxies that had no time to build, and light from stars that should not have existed yet. So either something was there before the wall, or the wall is not the beginning. And we do not know which. Everyone assumes the Big Bang is the beginning. Time equals zero. Nothing before it. But that is not what the physics says. The Big Bang is not an explanation of how the universe started. It is a description of the earliest state we can calculate backward to. A point where temperature and density go to infinity and the equations stop working. That is not a beginning. That is a wall. And we do not know what is on the other side. Was there something before? In 2020, Roger Penrose won the Nobel Prize partly for work on black holes, but he has spent years on something stranger. Conformal cyclic cosmology. The idea is that the universe expands until everything is dead. No structure, no matter, just empty radiation. And at that point, the dead universe becomes mathematically indistinguishable from a new Big Bang. The end is the beginning. And it has been happening forever. Cycle after cycle, universe after universe. Is there evidence? Penrose claims he found circular patterns in the cosmic microwave background. Rings that he says are echoes of black holes evaporating in the previous universe, bleeding through into ours. Most physicists are skeptical. The signal is faint, could be noise, but nobody has ruled it out. And Webb is taking the highest resolution measurements of the CMB ever. If those rings are real, Webb might find them. And if it does, then everything that has ever existed has existed before. So, have you been here before? Not you specifically, but something that thought and fell and wondered if it was alone. Has that happened 1 trillion times already? Was it erased every time? Did it come back every time? And is there any difference between something that repeats forever and something that happens once if the thing inside it cannot remember? We do not know which universe this is. We do not know if there were others. But in this one, right now, Webb caught something we have never seen in this much detail. A star in the exact moment of dying. And what it left behind is not what anyone expected. Webb pointed at the Southern Ring Nebula and caught a star mid-death. Not 1 million years after. Not the leftover. The act itself. A shell of gas expanding outward in real time. Layer after layer of material that the star spent billions of years building being thrown off into space. And inside that shell, Webb found something Hubble missed. A second star. The dying star is not alone. It has a companion, and the companion is shaping how the death unfolds. Pulling the gas into spirals and jets. Sculpting the explosion. The death of a star is not a single event. It is a conversation between two objects, and the pattern of what gets left behind depends on who else is in the room. And what gets left behind matters. Those layers of gas are full of heavy elements. Carbon, oxygen, silicates, the same materials that end up in planets and eventually in people. But Webb showed the chemistry is more complex than we knew. The gas is not just raw elements, it is already forming molecules, already organizing. The star is dead, and its corpse is already building the next thing. There is no gap between destruction and creation. Not even a pause. One is already inside the other before the first one finishes. So, you want to know what a dying star looks like up close. It looks like a factory that switched products without stopping the line, and Webb found something else in that image. The companion star that is shaping the nebula is still alive, still burning. It watched its partner die from close enough to sculpt the remains. And it will keep burning for billions of years, surrounded by the scattered body of something it used to orbit with. Is that all that is left when something dies? The shape it leaves in the things around it. Because Webb found another shape like that. Bigger. A galaxy that was hit so hard it is still ringing from the impact. And inside that ring, something is being born. About 300 million years ago, a smaller galaxy punched straight through the center of a larger one. Passed right through it like a bullet through a window. And the larger galaxy did not collapse. It rang. The impact sent a shockwave outward from the center like a ripple in a pond. And that ripple is still moving. Webb photographed it in 2022. The Cartwheel Galaxy. A ring of bright blue stars circling the outside edge where the shockwave is right now. New stars igniting along the front of the wave as it pushes through the gas. Billions of stars that would not exist if the collision had not happened. So a galaxy was destroyed, and the destruction created more stars than the galaxy had before it was hit. The ring is a nursery built from violence, and it is not slowing down. The wave is still expanding, still igniting new stars at the edge, still building, and in a few 100 million years those stars will form planets, and some of those planets will cool, and maybe on one of them, something will wake up and look at the sky and have no idea that everything it sees only exists because two galaxies collided before it was born. And this is not rare. Webb has found collisions and mergers everywhere it has looked. Galaxies do not sit still. They pull on each other. They orbit. They crash. Stefan's quintet, 5 galaxies locked in a slow collision that has been going on for millions of years. Webb captured shockwaves between them larger than our entire galaxy, gas being heated to millions of degrees, stars being ripped from one galaxy and thrown into another. And in the middle of all that chaos, new stars forming. Always. No matter how violent the collision, there is something being built inside it. And it is coming for us. The Milky Way and the Andromeda Galaxy are moving toward each other at 300 kilometers per second. In about 4.5 billion years, they will collide. Not a bullet through a window this time. A slow merger. 2 spirals twisting into each other over hundreds of millions of years. Our sun will probably survive. It will be thrown into a new orbit in a new galaxy that does not look like either of the originals. The night sky will be unrecognizable, and whatever is alive on Earth at that point, if anything, will watch the sky change shape in real time. But that is 4.5 billion years from now. And there are things much closer and much stranger that we barely understand. Because when Webb looked at our own solar system, it found something on a planet we thought we knew. And we were wrong. Neptune, the farthest planet in our solar system. We sent Voyager 2 past it in 1989 and took a few photographs. And that was it. For over 30 years, that was everything we had. A handful of images from a probe that is now 14 billion miles away and cannot come back. And in those 30 years, we assumed we knew what Neptune looked like. Blue, cold, distant, done. In 2022, Webb pointed at it and everything changed. It captured Neptune's rings for the first time in 3 decades. Not just the bright main rings, faint, dusty rings that Voyager never saw, structures in the ring system that do not match any model we have, and the planet itself looked different. In infrared, Neptune is not blue, it is dark, almost black, with bright streaks of methane, ice clouds at high altitude, and a strange bright spot at the South Pole that nobody can explain. A planet we have known about since 1846, and we are still finding things on it that do not match what we expected. And then Webb looked at Uranus. Same story. Rings we had never seen clearly. 11 of 13 known rings visible for the first time in a single image. And moons. 27 known moons orbiting Uranus, and some of them showed up in the Webb images in positions that do not match our predictions. Our orbital calculations for objects in our own solar system are off, not by a lot, but enough to notice. And if we cannot get the orbits right for moons circling a planet 3 billion kilometers away, how confident are we in anything further? We have been staring at the edge of the universe for 3 years, finding galaxies and black holes and supernovae billions of light years away. And we cannot describe what is happening on the 8th planet in our own system. We live here. This is our neighborhood. And we barely know it. So what else is sitting in our solar system right now that we have not looked at properly? What is hiding in plain sight, close enough to reach but too familiar to bother checking? Because Webb turned that same infrared eye on something even closer. A planet we have studied for centuries. And it read the atmosphere of a world outside our system with more precision than we have ever read anything. And what it found in that atmosphere rewrites what we think a planet can be. In 2022, Webb did something no instrument had ever done before. It took a full chemical inventory of the atmosphere of a planet outside our solar system. The planet is called WASP-39b, a gas giant about the size of Saturn orbiting its star so close that a year there lasts 4 days. Surface temperature over 800 degrees Celsius. Not a place anything could live. But that is not why it matters. It matters because of what Webb found in the air. Carbon dioxide, confirmed for the first time ever in an exoplanet atmosphere. Sodium, potassium, water vapor, and something nobody predicted. Sulfur dioxide, a molecule that on Earth is produced by volcanoes and industrial pollution. On WASP-39b, it is being created by sunlight hitting hydrogen sulfide in the upper atmosphere. Photochemistry, the same type of process that drives the ozone layer on Earth. The same type of process that might have kickstarted the chemistry of life on early Earth. Happening right now on a planet 800 degrees hot with no surface to stand on. So the chemistry is not waiting for the right conditions. It is running everywhere, on boiling gas giants with no solid ground, in clouds of sulfur and hydrogen, under radiation that would kill anything we know of. It does not care. Give it atoms and energy and it starts building. And the combinations it builds are not random. They are the same ones we see everywhere. The same molecules, the same reactions, the same pathways. The universe has one playbook for chemistry, and it runs it on every planet it can reach, regardless of whether that planet could ever support life. And that is what should bother you. Because if the chemistry runs everywhere but life only shows up in a few places, then the filter is not at the chemistry stage. The chemistry is easy. The chemistry is automatic. Whatever stops life stops it after the chemistry is already going. After the molecules are already built. After everything is in place and ready. Something shuts it down at the last step. Or the second to last. Close enough to the finish line that it already looked like it was going to work. And we do not know what that something is. But Webb keeps finding the pieces in places where the final thing never showed up. So what is the missing piece? What turns chemistry into biology? Because Webb found something that might be the closest we have ever come to seeing that line. And it is not on a planet. It is floating between the stars. In 2023, Webb found complex organic molecules floating in interstellar space. Not on a planet, not in an atmosphere, in the void between stars, polycyclic aromatic hydrocarbons. Long chains of carbon and hydrogen arranged in rings. The same class of molecules that on Earth form the backbone of DNA. And they were just drifting. No star nearby. No planet. No source anyone could identify. Just chemistry assembling itself in the dark between stars, as if it had somewhere to be. And it was not just in our galaxy. Webb detected the same molecules in a galaxy outside the Milky Way, billions of light years away. A completely separate system with its own stars and its own history and the same carbon chemistry floating in the same kind of void. So, the recipe is not local. It is not something our galaxy invented. It is universal. The same molecules that sit inside your cells right now are being assembled independently in galaxies that have never had any contact with ours. And then Webb looked closer to home, at comets and icy bodies in our own solar system, and found the same thing. Carbon dioxide, carbon monoxide, complex organics frozen into the ice of objects that formed at the very beginning of our solar system. These are not things that developed later. They were baked in from the start. Before the Earth existed, the raw materials for life were already circulating in the disk of gas and dust that would become our planets. The chemistry did not wait for the planets to form. It was already there waiting for somewhere to land. So follow the chain. Complex organic molecules assembling themselves between stars. The same molecules frozen into comets and asteroids. Those comets hitting young planets and delivering the chemistry directly to the surface. And on at least one of those planets, the chemistry kept going and became you. That is not a theory. Every step of that chain has now been observed. Webb has photographed every stage. The only step it has not seen is the exact moment dead chemistry becomes alive. Everything before that moment is confirmed. Everything after that moment is us. And that gap between confirmed chemistry and confirmed life is the smallest it has ever been, which means the answer to whether we are alone might not come from listening for a signal. It might come from watching that gap close. But while we watch, Webb keeps finding things we were not looking for. And one of them has been hiding in our galaxy this whole time. Not a star, not a planet, something in between. And there are billions of them. A brown dwarf is a failure. It is what happens when a cloud of gas collapses and starts to form a star but does not have enough mass to ignite fusion. Not enough pressure, not enough heat. It gets close and then it stalls. Too big to be a planet. Too small to be a star. Just a hot, dense ball of gas slowly cooling in the dark. And before Webb, we thought they were rare. Background noise. Cosmic leftovers that did not make the cut. Webb proved that wrong. In 2023 and 2024, it found them everywhere. Free floating in nebulae, orbiting stars, drifting alone through open space with no star system at all. Some of them in pairs orbiting each other. 2 failed stars circling in the dark with nothing else around them, and the numbers are staggering. In some star-forming regions, Webb found nearly as many brown dwarfs as actual stars. They are not rare. They might outnumber stars in parts of the galaxy. We just could not see them before because they barely glow. And some of them are stranger than they should be. Webb measured their atmospheres and found clouds. Not water clouds. Silicate clouds. Clouds made of sand and molten rock, floating in the atmosphere of an object the size of Jupiter that is not orbiting anything. Weather on a world that has no sun. And some of them are so small, they blur the line completely. Masses only a few times larger than Jupiter. Is that a planet or a failed star? The categories we built do not hold. The universe does not sort things into the boxes we made for them. So what does that mean? It means the space between stars is not empty. It is full of objects we could not see until now. Billions of hot dark masses drifting through the galaxy. Some of them with atmospheres and weather and chemistry, and we had no idea they were there. What else is out there that we have been looking past? What else is drifting between the stars too dim to notice but massive enough to matter? Because Webb found something else hiding in plain sight. Not between the stars, but inside them. Stars in our own galaxy that are almost as old as the universe itself. And they should not still be here. There are stars in the Milky Way that were born less than a few 100 million years after the Big Bang. Not in a distant galaxy 13 billion light years away. Here, in our galaxy, orbiting the same center we orbit. Some of them close enough that Webb can study their chemistry in detail, and they should not exist. Not here. Not anymore. Stars that old should have burned out or exploded or been swallowed by something billions of years ago. But these are small. Cool. Red dwarfs and subdwarfs with so little mass they burn their fuel almost not at all. They have been quietly glowing since before the Earth existed. Before our sun existed. Before most of the galaxy existed. They watched everything form around them. And Webb read their light and found almost no heavy elements. Almost pure hydrogen and helium. Which means they formed before the first generation of massive stars had time to explode and seed the gas with heavier materials. These are among the first objects that ever formed in our region of space. And they are still here. Still burning, still orbiting. You could point a telescope at one tonight, and the light hitting your eye left a star that remembers a universe you would not recognize. So, the oldest things in the universe are not far away. They are next door, circling the same galaxy you live in. And they carry a record of what the universe looked like before anything we know existed. A chemical fingerprint of the first few 100 million years written into their atmospheres. Webb is reading that fingerprint right now, and every time it reads one, the chemistry does not match what our models say should be there. Too little lithium. Wrong ratios of carbon to iron. Small details that do not add up. Which means either our models of the early universe are wrong, or something happened in those first few 100 million years that altered the chemistry before these stars formed. Something we have not accounted for. And the tool Webb uses to read these fingerprints is the same tool that lets it see things that should be invisible. Because Webb does not just look at light, it looks at light that has been bent. And what the bending reveals is something we cannot see any other way. Gravity bends light. Einstein predicted it. Eddington confirmed it in 1919. If something massive sits between you and a distant object, the gravity of the massive thing curves space, and the light from the distant object bends around it. The object behind gets magnified, distorted, sometimes duplicated. You see multiple copies of the same thing arriving at different times because the light took different paths around the lens. It is called gravitational lensing, and Webb uses it as a telescope on top of a telescope. In 2023, Webb pointed at a galaxy cluster called Abell 2744. The cluster is so massive it bends the space around it like a bowl. And behind it, thousands of galaxies that are too faint and too far to see with any instrument ever built appeared in the image, magnified, stretched. Some of them from the first billion years of the universe. Webb did not find them by being powerful enough to see that far. It found them because the universe itself acted as a lens. The universe showed Webb things that Webb could not have seen on its own. And that means everything we have found so far is limited by where the lenses happen to be. We can only see the ancient universe in the places where a massive cluster happens to sit between us and something behind it. Change the angle and those galaxies disappear. They are still there, but we cannot see them without the lens. So how much are we missing? How many galaxies from the first billion years are sitting in parts of the sky where there is no lens to magnify them? Webb has surveyed a tiny fraction of the sky, through a handful of lenses, and it already found galaxies that broke every model. What happens when we look through more? What is sitting in the parts we have not checked yet? Because behind one of those lenses, Webb found something specific. An engine of destruction that was already running when the universe was 700 million years old. And it was eating everything around it. Quasars. The brightest objects in the universe. Each one is a supermassive black hole eating so much matter so fast that the friction of the infill generates more light than an entire galaxy. A single point outshining 1 trillion stars. And Webb found them at the edge of everything. In 2023 and 2024, it detected quasars active when the universe was less than 700 million years old. Already running, already consuming, already blasting radiation across entire regions of space. And the black holes powering them are too big. Hundreds of millions of solar masses already locked into a single point before the universe had its first billion years. The same problem Webb keeps finding everywhere it looks at the early universe. Too much too soon. But quasars add something else. They do not just sit there and eat. They transform everything around them. The radiation pouring out of a quasar heats the gas in its entire galaxy, stops new stars from forming, pushes material out into intergalactic space. A single quasar can shut down star formation across an area millions of light years wide. And then, when the black hole runs out of fuel and the quasar goes quiet, the gas cools and stars start forming again. One object controlling the life cycle of an entire galaxy. So galaxies are not independent things. They are controlled by what sits at their center. And what sits at their center got there by a process we do not understand in a time frame that should not be possible. Our galaxy has one too. Sagittarius A star. It is quiet now. We covered what happens if it wakes up. But the quasars Webb found were not occasional eaters. They were running constantly at full power for millions of years. And they were everywhere in the early universe, which means the default state of a galaxy is not peaceful. The default is violent. What we have right now, a quiet center, a stable disk, predictable orbits, that is the exception. And exceptions do not last. But for now, we're in one. And there is one more thing Webb found that says more about this moment than anything else. The chemistry of everything around us. And it started with dust that should not be there. Dust is everywhere in the universe. It fills nebulae. It coats protoplanetary disks. It blocks light from distant stars. It is what planets are made of. Without dust, there is no Earth, no rock, no iron, no you. And dust is made inside stars. When stars burn, they fuse elements into heavier elements, and when they die, they scatter those elements as tiny solid grains. That is where dust comes from. Stars have to live and die first. Then there is dust. That is the order. There is no other way to make it. But Webb found dust where there has not been enough time for it to exist. In galaxies from the first billion years. Galaxies so young that only one or maybe two generations of stars could have lived and died. And the amount of dust Webb found is enormous. Far more than one or two generations of stars could have produced. The math does not work. You need dozens of cycles of stars living and dying and scattering to build up that much dust. And there have not been dozens of cycles. There have barely been one or two. So, where did it come from? The honest answer is we do not know. Maybe the first stars produced more dust when they died than our models say. Maybe there is a process that creates dust without stars that we have not discovered. Maybe supernovae in the early universe were fundamentally different from the ones we see today, and they scattered more material per explosion. Every explanation requires changing something we thought we understood. And this is not a small problem. Dust is not decoration. It is the raw material for everything solid. If we do not understand where it comes from, we do not understand how planets form, how solar systems form, how the ground under your feet got here. And Webb keeps finding it. In every early galaxy, it looks at there is more dust than there should be. Always more, never less. Whatever process is making it is more efficient than anything we have in our models. So either our models are wrong about how stars die, or there is an entire category of dust production that we have not found yet. Something that was running hard in the first billion years, and we cannot see it. But dust is not the only thing Webb found too much of too early. In a small galaxy outside the Milky Way, it found stars being born in a place where star formation should have stopped long ago. And the reason it has not stopped changes what we think drives the whole process. NGC 346, a star-forming region in the Small Magellanic Cloud, a dwarf galaxy orbiting the Milky Way. It is small, it is old, it has very few heavy elements. By every model we have, it should be winding down. Star formation requires gas and dust and the right conditions, and this galaxy has been losing all three for billions of years. It should be quiet by now, almost done. But in 2023, Webb looked at NGC 346 and found the opposite. Thousands of young stars still forming, protostars still pulling gas onto themselves, disks still spinning around them. An entire nursery running at full speed in a galaxy that does not have the resources to support it. The gas is too thin, the dust is too sparse, the heavy elements are almost gone, and it is still building stars. Something is driving star formation in conditions where it should have stopped, and this matters because the Small Magellanic Cloud looks like the early universe. Low heavy elements, thin gas, harsh radiation, the same conditions that existed in the first few billion years when the first galaxies were forming. And if star formation can keep running in conditions like that, then it could have been running harder and earlier than we thought in the ancient universe too. Which means more stars forming sooner, more planets forming sooner, more chemistry starting sooner. The window for life might have opened earlier than anyone calculated. So the universe is not winding down the way we expected. Even in the places that should be dying, something keeps building. Stars keep forming in galaxies that should be finished. Dust keeps showing up where it should not exist. Chemistry keeps assembling itself in voids between stars. And life started on Earth almost as soon as conditions allowed, as if it was waiting for the door to open. Is that a pattern? Is the universe not just capable of producing life, but driven to produce it? Does it lean toward complexity the way water flows downhill? Because if it does, then everything we have been afraid of looks different. Every extinction and every filter and every silent sky looks different if the universe is actively pushing toward life, rather than passively allowing it. And that is almost the end of what Webb has shown us. Almost. There is one more image, the first one it ever took, and it might be the most important one of all. The first full image Webb ever released was on July 12th, 2022. It is called Webb's First Deep Field. It shows a galaxy cluster called SMA CS0723. And in the background behind that cluster, stretched and magnified by gravitational lensing, are thousands of galaxies. Some of them from the first billion years of the universe. In a patch of sky no bigger than a grain of sand held at arm's length, there are more galaxies than anyone expected. Thousands of them, each one containing billions of stars. Each of those stars potentially orbited by planets in a single grain of sand. And this is one image, one tiny patch. Webb has taken hundreds since then. And in every direction, it points the same thing. More galaxies, more stars, more structure, more complexity. The universe is not mostly empty. It is full, overwhelmingly full, incomprehensibly full, and every single thing in every single one of those galaxies is subject to the same physics that governs you. The same gravity, the same chemistry, the same forces building and destroying at the same time. Everything Webb has found over 3 years is in that first image. The 2 early galaxies, the impossible black holes, the organic chemistry, the collisions, the dust, all of it is in there if you know how to look, and you are looking at it. That is the part that still does not make sense. A universe this large and this old and this violent produce something on one small planet that can take a photograph of the whole thing and feel something about it. You are not outside this image, you are in it. You are made of the same material as every galaxy in that frame. Assembled by the same process, subject to the same forces, and you are the only part of it that knows. The only part that looked back. Whether that means something or means nothing is not a question Webb can answer. It is not a question any telescope can answer. It is the question you are left with when the telescope is done, and it is yours. So what did Webb actually find in 3 years? It found that the planet we need to leave is orbiting a star that most planets do not get. That the backup options are dead. That the clock we are using might be broken. That the ingredients for life are everywhere and none of it survived. That the universe is 95% invisible and the biggest part of it is tearing everything apart. That the rules we use to predict what happens next do not work at the beginning and might not work now. That the structures holding everything together are made of something we cannot name. That the first things to exist were already too big and too complex and too early. That stars are dying faster than they are being born. That the chemistry of life assembles itself automatically in the dark between stars. That galaxies collide and build and destroy in the same motion. That there are billions of objects drifting between stars that we never knew about. That the dust we are made of showed up before it should have. And that in a single grain of sand aimed at the sky, there are more worlds than anyone alive will ever be able to count. And you looked at all of it. Every image, every number, every impossible thing, and you are still here. The universe did not ask you to look. It did not build Webb. It did not decide to find out what it is made of. You did. A thing made of dead stars on a temporary planet around an ordinary star, in one arm of one galaxy, in one corner of a web, it cannot see, decided to point a mirror at the edge of time and ask what is out there. And when the answer came back, and the answer was mostly dark, and mostly violent, and mostly empty, and mostly dying, you did not stop. You kept looking. That is not nothing. Out of everything the universe has made in 13.8 billion years across 100 billion galaxies, the only thing we know of that has ever looked back at it is you. Not your species in the abstract. You, the one hearing this right now. You are the universe's way of seeing itself. And whether that was the point all along, or whether there is no point at all, does not change the fact that you are here doing it, right now, in the only window of time when the stars are still lit, and the chemistry is still running, and the light from the beginning is still arriving. So yes, the planet will not last. The star will not last. The galaxy will not last. The universe itself will cool and empty and go dark. Everything Webb has shown us says that the window we are in is small. Smaller than anyone thought before Webb flew, and everything outside that window is either not yet built or already gone, but you are inside it, right now, at the one moment in the entire history of everything when there is something here that can look at all of it and understand what it is seeing. And that window is not just a cosmic accident, it is yours. Every morning you wake up in it. Every conversation you have happens inside it. Every person you have ever loved exists in the same sliver of time between the first light and the last star. And no telescope will ever tell you what to do with that. No equation will solve it. No model will predict what matters and what does not. That part is not physics. That part is you. Webb was built to answer the biggest questions humans have ever asked. Where did we come from? Are we alone? How does it end? And the answers it sent back are harder than anyone expected. The universe is more hostile and more beautiful and more strange and more indifferent than we thought. But it also did something nobody planned for. It made the small things look different. When you know the stars are dying, the light they give off right now matters more. When you know the window is closing, the fact that it is still open matters more. When you know how unlikely it is that you exist at all, the fact that you are here right now matters more. That is what Webb gave us. Not comfort, not reassurance, perspective. The kind that does not make your problems disappear, but makes them the right size. Because in a universe this old and this large and this violent and this silent, whatever you are dealing with right now, you can handle. It is small. Not because it does not matter to you. It matters. But because you are the only thing in 100 billion galaxies that anything has ever mattered to. And that makes you the most important thing the universe has ever produced. Not because it meant to, but because nothing else it made can carry meaning at all. Only you can do that. And that is where I will leave this. 3 years of James Webb. 41 discoveries, and one question that none of them could answer. What do you do now? I do not know what you believe. I do not know if you think the universe was designed, or if it is an accident, or if it is one of an infinite number running at the same time. But I know you are still here. And I know you watched this whole thing, which means you care about the answer even if you do not have it yet. So leave it in the comments. Tell me what you think. Not what you know. What you think. What does any of this mean to you? What changed? What did not? I read every single one. If this made you think about something you have not thought about before, hit the like button. If you want more like this, subscribe. And if someone you know needs to hear this, send it to them. Because this stuff is too big to sit with alone. This has been Acronium. See you next time.